Here we will see types of parallelism in C#. Parallelism is an important concept in programming because it divides tasks and allocates those tasks to separate threads for processing. In .NET, for parallelism, you can use the system.threading and system.threading task namespace. These namespace provide several classes and methods to help you to implement parallelism in your .NET applications. In C#, you can use several types of parallelism to optimize your code and increase efficiency. But the most important ones are data parallelism and task parallelism. First is data parallelism. Data parallelism is about dividing a large data set into smaller chunks and processing all the chunks in parallel. This is a common technique when there is a large number of datasets that need to be processed. In C#, the parallel class provides a set of methods for performing data parallelism such as parallel.for and parallel.foreach. Data parallelism is basically used in image processing where each pixel or group of pixels can be processed independently. And next is task parallelism. Task parallelism is another parallelism type and it is about running multiple potentially unrelated tasks concurrently. It is useful when you have a multiple independent and unrelated tasks that you want to execute simultaneously without having them wait for each other. For example, you are listening a podcast and also type a blog post or downloading multiple files. Choosing the right parallelism technique depends on user-specific use case. Difference between data parallelism and task parallelism is, in data parallelism, some tasks are performed on different subsets of same data, whereas in task parallelism, different tasks are performed on the same or different data. Synchronous computation is performed in data parallelism and asynchronous computation is performed in task parallelism. In data parallelism, there is only one execution thread operating on all sets of data, so the speedup is more. And in task parallelism, each processor will execute a different thread or process on the same or different set of data, so speedup is less. In data parallelism, amount of parallelization is proportional to the input size. And in task parallelism, amount of parallelization is proportional to the number of independent tasks is performed. Data parallelism is designed for optimum load balance on multiprocessor system. In task parallelism, load balancing depends on the availability of the hardware and scheduling algorithms like static dynamic scheduling.